Hello, geometry students. This is Miss Graham, and today we are going to be looking at lesson 18.1, similarity criteria. Remember, this is under unit 3 of our textbook, similarity and trigonometry. Go ahead and pull out pages 257 through 261. Today, we're going to be focusing on the following learning targets. We're going to develop criteria for similarity in triangles. And then we're going to prove different similarity criterion. We're going to see something that's called AA, and we're also going to keep emphasizing, okay, what's the difference really between similarity and congruence? And we're going to compare really, okay, how do we compare the similarity of triangles, and how is that different or similar to seeing the congruence of triangles? So what we're going to do over into the margin on the right side is we are going to make a little bit of a table. And what we're going to do is we're going to compare what we know on triangle congruence, and then we're going to compare it to triangle similarity. So this is going to show on the left column triangles are congruent. And then on the right side, we're going to show how triangles are similar. Now this symbol that I just used right here, that means similar. So up at the top, I will say just as a reminder that this is comparing congruence and this is comparing similarity. So as a nice little review, let's remind ourselves of what shows triangles are congruent. Remember, we did this before winter break where we went through all the different methods of showing that triangles are the same size and same shape. Remember, that's what congruence is. That's same size and shape. So we prove this through side, side, side. We prove this through side, angle, side. We also did angle, side, angle. We also did angle, angle, side. And then we looked at RHL, maybe some of you call it HL, where we have a right triangle or right angle. One of our hypotenuses and one of our legs is congruent. So now what we're going to start investigating today is, well, how do we show triangles are similar to each other? Are we going to be using some of these same methods? Or are we going to be using different methods? So keep this kind of chart in mind. We're going to be coming back to it. Let's go ahead and start reading our background information that's going to tie all this together. So it says, a land boundary dispute exists between a national park and a bordering landowner. Surveyors have been hired to determine land boundaries and help settle the dispute. The surveyors will use similar triangles to find the measurements. You learned in Unit 2 that it's not always necessary to use the definition of congruence to determine if triangles are congruent, because there are congruence criteria you use to show two triangles are congruent. So what it's saying here is that we don't need to know all the sides and angles of our two triangles are congruent. We can use minimal information to show that. So in a similar way, we can look for criteria to show triangles are similar. Now, as a reminder before, we went over what similar means with triangles. So down here at number 1, it starts with saying, recall that if two figures are similar, so we're going to recall that if two figures are similar, if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. So maybe one is half the size of the other, maybe one is 3 times the size of each other, maybe the other one is 4.5 times smaller. That's what we're talking about here. So remind ourselves if that's what's the difference between similarity and congruence. So what we're going to write up here, right in our chart, is that we know it's not going to be the same size, it's going to be the same shape, essentially, right? So we're going to have the same shape, but they're going to be different sizes, right? So that's something we can start to think about. Now, since we're learning about similarity criteria for shapes or specifically triangles, since we're looking at it digitally through a video, what we're going to do is we're going to skip around to different parts of this lesson so that way we can focus on which methods that we're going to learn to show that triangles are similar. Now, before we jump around, I'm going to start off with kind of another question. So I'm going to scoot on down here and off to the side. All right, so let's think about, just as a reminder again, let's say we have a triangle right here. All right, I know it's not the best drawn triangle, but it's a triangle of some sorts. And let's say that I dilate the triangle, all right? So dilate, remember, means that we can make it bigger or smaller. But think about what stays the same, okay? When you dilate your triangle, all right, what stays the same? Well, we already know from before that we have the same shape, but I'm also going to ask you, to dig a little deeper, all right? Not just the same shape, but think about what specifically stays the same. So that's kind of our driving question. So what specifically stays the same? That's going to help us figure out what reasons we're going to use to show two triangles are similar to each other. So we're going to go ahead and use this question as a driving force. What we're going to do is we're going to skip to number 4. So we're going to skip numbers 1, 2, and 3. Skip to number 4, which is on page 258. So we are on the next page, and we are going to be zooming in to number 4 here. And maybe some of you already started thinking about, okay, what we can fill in on that chart. That's what's going to help us out here. So let's start reading up above here. It says, you can use the AA similarity postulate to show that two triangles are similar. So AA, let's focus in on that. That means angle, angle. Is that what some of you were thinking about? You're thinking about, oh, the angles stay the same. So when we have the same shape, even if it's not the same size, the angles are going to stay the same. So in order to prove, let's try that again. In order to prove why this criterion works, you must show that it follows the definition of similarity in terms of rigid motion. So it says to justify the AA similarity postulate, consider the two triangles below. So we have triangle ABC, triangle DEF. Now we have the correct angle markings for 2 of the angles. So let's write that down. What given information is marked in the figure? Well, we can see that we have angle A is congruent to angle D, and we know that angle B is congruent to angle E. So let's look at the next question. It says, based on the definition of similarity, explain whether the transformations can show that ABC is similar to DEF. So think about this, right? A sequence of similarity transformations, right, will map these two on top of each other, these two triangles. Remember, similarity transformations can include dilations, right? Because that can change the size. That's okay to do that. So let's go ahead and answer this question. So we're going to say a sequence of, we're going to try that symbol again, of similarity transformations which include dilations will map triangle ABC to triangle DEF. So all in all here is what we're saying is that we can go through different types of transformations, including dilations, to show that these two triangles map on to each other, right? That we're going to be able to do that. We can make this triangle bigger, and it'll map onto that triangle because we know two angles are congruent. Now, some of you might be thinking, well, why isn't this angle, angle, angle? Why isn't that the similarity postulate that we're looking at? Well, keep in mind, we're looking for the minimal amount of information to prove that two triangles are similar. We automatically know that all the angles in a triangle add to 180 degrees. If this, let's say, was 20 degrees, this was 20 degrees, and let's say that this was 80 degrees, this was 80 degrees, together we have 100 degrees in these two angles. So our remaining angle must be 80 degrees. We automatically know that third angle has to be the same for both of those. So this way, we don't necessarily have to say that we need all three angles. We could just have the minimal information of two angles since this third angle was already assumed to be the same. Now, remember what we proved a long time ago before winter break, we can't just have one angle that's the same. We have to have two in order for similarity here. So what we know from our angle-angle similarity postulate is if two angles of a triangle are congruent to two angles of another triangle, then the triangles are similar. That's why it's the AA similarity postulate. We're going to go ahead and skip the rest of number 4, and we're going to talk about another similarity postulate that we can find. We're going to go to number 5, and we're just going to look at the paragraph, the one paragraph right above number 5. So go ahead and head to the next page, 259. All right, so we're going to zoom in here to number 5, just looking at the paragraph right above number 5, what we have up here. Okay, so you learned there were 6 criteria for showing that triangles are congruent. So it seems logical, well, we really only focused on 5 of them. So that's something to kind of keep in mind. So we only had 5 criteria for showing that triangles are congruent, okay? So it seems logical that there may be other criteria for showing that triangles are similar. Okay, so we're going to first investigate whether there is an SAS similarity criterion. So looking at this, it says, how do you think the SAS similarity criterion differs from the SAS congruence criteria? So think about that. Think about how is similarity different from congruent? Now, remember, with congruence, we know that the side lengths have to be equal. Whereas if we're looking at similarity, we know the side lengths just have to be proportional. So that's what we're going to focus in on. So we're going to say in SAS congruence, the corresponding sides are congruent. And then we're going to say in SAS similarity, the corresponding sides are proportional. Whereas the angle will still be the same in both of them. So now let's look at part B. It says state what you think the SAS criterion would say. So looking at this, what we could say is if two sides of a triangle are proportional to two sides of another triangle, and remember, we are talking about that included angle. We could say the included angle is congruent, then we know the triangles are similar. So let's write that down. So we're going to say if two sides of a triangle, there's our triangle, we're going to say are proportional. So if two sides of a triangle are proportional to two sides of another triangle, and the included angles are congruent, then the triangles are similar. So keep in mind how this is different. SAS similarity is different from SAS congruence. All right, you know the drill. We're going to go ahead. We're going to skip to number 6, which is at the top of the next page, 260. So we are at the top of the next page. Perfect. Looking at number 6. All right. So we've already looked at 2 methods of similarity criterion. We looked at side, angle, side, and we looked at angle, angle. So let's look at number 6. Now investigate whether there is an SSS similarity criterion. So how do you think the SSS similarity criterion is different or differs from the side congruence criterion? So maybe look at what we just put for number 5A. Go ahead, pause the video right here. I want you to take the time to answer this. All right, let's go ahead and look at this. So I said in SSS congruence, the corresponding side lengths are congruent, or we could say are equal in measure. Whereas in side or SSS similarity, the corresponding sides are proportional. So there is some number that we multiply all the sides by to get to the other side lengths, whereas this could increase or decrease the triangle size, right? Different dilations. All right. So now it's your turn again. All right. I want you to go ahead and state what you think the SSS criterion would say. So we've already gone through AA criterion. We've already gone through SAS criterion for similarity. Now I want you to try SSS, or side, side, side. All right, here's what I wrote down. I said if three sides of a triangle are proportional to three sides of another triangle, then the triangles are congruent. Oops, sorry. Then the triangles are similar. So do you see how easy it is to slip up on the symbols, knowing congruence versus similar? So just be careful, be mindful of that, because, you know, I've been teaching this for a while. I still tend to slip up on those, but that's okay. Just at least acknowledging and knowing that similarity is different from congruence. So now here's what we're going to do. We're going to go back to that chart that we made before. What I'm going to do is I'm just going to copy and paste and put into the margin. And we're going to fill in those three rules that we came up with for similarity criterion of triangles. Alrighty, so I copied and pasted it to the left. You can go back and refer to your chart before if you would like to do that. But what we're going to do is we are now going to fill in what similarity criteria that we found today. So the most recent one that we went over was side, side, side. So ironically, you can see that we have that matching for congruence and similarity. The next one we had was side, angle, side. So again, you can see we had that incongruence as well as similarity. Now the first one that we went over was angle, angle. So that one doesn't match looking at any in the congruence column. So that one's kind of one on its own. So that's something to kind of keep in mind as we're looking through this. So we just went over three ways that we're looking at triangles are similar to each other with the minimal amount of information. What you can do right now is you can look at your teacher's calendar or refer back to what your teacher has for today's homework and see what you are going to be working on. Happy mathing, y'all. So specifically for Miss Graham's class, what you're going to be looking at for tonight's homework is we are going to be looking at page 260 as well as 261. So our first homework problem will be number 7 on page 260. And then let's go to page 261 to see which problems we're going to be doing after. So Miss Graham's class is going to be doing number 7 from the previous page, as well as numbers 8, 9, 10, 11, 12, 13, and 14. Now, this may seem like a lot of problems, but looking at this, make sure you read through the directions, read through all the directions for each of these, and try to do your best in exploring and explaining, okay, are we able to prove triangles are similar or not? All right, so now is the end of the video for Miss Graham's class. So have a good rest of the day, and we will see you tomorrow.